Okay. Full screen. Good, okay. So you're happy with that idea, that word. The domain of a function fx is the set of values x can be. So let's have a look at some examples of calculating, or not so much calculating, but finding the range. So I'll do some examples now. Can I scroll down? Don't worry, I mean, if you have the definition in your words, that's fine, okay? Alright, so I'll scroll down now. Right, so here's my first example. Function f of x equals minus 9x minus 7. Okay. So who knows? I mean, the way you do these in your head is you have to ask yourself, is there any time I might have a problem with my x? So what about this one? What is the domain? What values of x can I use?
7 over 9. Minus 7 over 9.
No?
So it's begin.
No, it's fine. 0 is fine. So yeah, the answer here, you can use any number, can't you? Is there any number you cannot use for x here? Is there any number forbidden? No. So we can use all real numbers here. There are no forbidden numbers. So you can see there's nothing for me to write, because there's nothing for me to do. I just need to know this. Okay, what about this one? Fx equals 3x squared plus 5x plus 3. What do we think? It's the same. Oh, I'm writing fx, but I changed the letters sometimes. Alright, I think we get the idea here for these ones. What's the domain here? What's the domain? Yeah. So we like linear, quadratics and cubics because we can use any number in them. Now let's start making it a bit more difficult. Very good. Say that again? You're right. So how could I write the domain?
R except 2.
Yeah, you can write it this way, or except 2. That's one way to write it. You can't use 2 here, it's forbidden. But if you want, you can write it like this, minus infinity to 2, and then 2 to infinity. And you see, you're not including the 2. Both are acceptable, but please be careful. In the exam, they may say, what is the set? So please look for this keyword in the question, set. If they say that, it's probably meaning that they want the answer written like this. So it's much better if you learn how to write the answer like this, because sometimes they actually ask you to do it this way. These are the small things that cost people 1 or 2 marks. Okay. Now, there's actually a typo here in the book. I'm actually doing A, B, C, D. If you look at E, it says x squared. Oh no, there is no typo. Alright, I fixed it. Thank you, past Stephen. Alright. Fx equals 1 over x squared minus 39x plus 374. Right, so now it's getting a bit more difficult, but still not too difficult, I hope. How can I find the domain here?
By minus b plus minus.
Yeah, I think you all see that the first thing you need to do before you do anything is solve that quadratic. And those values are allowed or not allowed? Not allowed. Can we factorize this, or do you just want to use the formula? Let's see. Minus b plus minus square root b squared minus 4ac all over 2a. Yeah, please tell me. This equals 17 or 22. So now we have the domain equals all real numbers except 17 and 22, because they're forbidden.
Do we write it 1722 or negative 1722?
Oh, I'm sorry, was it 17? I mean, from this formula, did you get 17 or minus 17?
This is 17.
Yeah, so this formula is the formula for x. You're thinking of making it into factors, I think. If it's what? Oh yeah, it's a set. So if you want to write the answer as a set, it'll be minus infinity to 17, 17 to 22, 22 to infinity as a set. All good?
Yeah.
Yep.
Why didn't we say that 22 to...
22 to infinity?
Yeah, without the one infinity.
Ah, so your question is, why do I need this one too?
Yeah.
Well, because I'm saying here I can't use 17 and I can't use 22, but I can use the numbers in the between them. You know, if you draw the number line. Yes, I stop? Okay. Right. Now, let's have one with an e in it. So fx equals e power 13x plus 16. Yeah, so give me the answer. Domain is? Yeah. You can put anything into E. Right, now let's make it a bit more difficult. Let's have a log and a quadratic.
So if I
Yeah.
so A, it's always up.
Well, in this case it is, but I could do something sneaky, like, for example, if I said e power 1 over x.
Yeah.
Yeah. See, I'm sneaky like that. You have to be careful. Log x squared minus 11x plus 18. So I don't expect you to see the answer straight away, but what do you think we should do first?
Factorize.
Could factorize is one thing, yeah. So the problem here is with the log. What can you use for log? No, what I mean is what can you put into log? Can't be negative and can't be 0. So you want x squared minus 11x plus 18 to be bigger than 0, true? You've seen this problem in semester 1, chapter on algebra. The last lesson, chapter 1. So you're right, we have to factorize. I think it'd be 2 and 9, yeah. Minus 2, minus 9. So do you remember what to do next? We do the graph. Where does it cross? At 2 and 9. And do I want above or do I want below?
Below.
Above. Yeah, I want above here because it's bigger than 0. It's positive. So that means x must be smaller than 2, or you could have x is bigger than 9. So now we have to write the domain. You can use all the numbers smaller than 2, or all the numbers bigger than 9. But you can't use the numbers between 2 and 9. So now we're starting to look at what these will be like in the exam. Something like this is just too easy. You could get something like this in the exam, or something like this, you know. In other words, the questions in the exam require some calculation. It's never really a direct answer, like in my first example. Okay, do you have that written down? I'll do the next one. I will do 2 more, maybe 3. Who knows? Maybe 3. Okay, can I scroll down to the next one? Yeah. Okay, so the next one we have fx equals log 16x minus 16. Well, it's just like the last one except it's easier. You need 16x minus 16 to be, bigger than 0. So you need 16x to be bigger than 16. So you need x to be bigger than 1. So the domain is all the numbers bigger than 1. Okay, I'll skip J. So far what I've done is A, B, C, D, E, F, G, H, and I. I'm going to skip J because for some reason it's exactly the same as I mean the same type. So I'll go on to K now. Sorry, do you have that? Yeah? Okay. So I'm skipping J and now I'm looking at K. Fx equals x squared minus 4x minus 12 over x squared minus 5x plus 4. So, no surprise here, we should factorize first. On the top, 6 and 2, plus 2. And then on the bottom, minus 4 minus 1. So think carefully before you speak. What's the domain here?
24 and 1.
Yep. So that's the answer. The domain domain is all real numbers except for 1 and 4. Can you use 6? Of course. You just get 0, but that's fine. And could you use minus 2?
Yes.
Okay. Now I want to give you another one like this. It's not in the book, and I just thought of it. So, can I go to the side? Can I? No, you need a minute.
No, I think.
Can I go to the side? Yeah? I'll let you try this for a minute. Okay, give me the domain of this.
Cannot be minus 1, minus 6, and minus 1. And 1 and...
Did I do this right? Oh, sorry, hang on. I think you...
And minus 1.
I think you... Did I factorize this wrong in my head? On the top we get x minus 2, x minus 1, yeah? And on the bottom?
That's minus 6.
No, that's not right. I think you have the wrong numbers there. X minus 2, x minus 3. Yeah? Alright, try it again. So what's the domain here? Domain is all real numbers except 1 and 3. Wow. 2 and 3? Only 3? Only 3? Yeah. 1, 2, 3. So it seems like we have some people thinking 2 and 3, all real numbers except 2 and 3. And then we have some people thinking all real numbers except 3. So the first, who thinks it's all real numbers except 2 and 3? Who are those? Okay? And who thinks all real numbers except 3? So this is more popular. And what's the reason for this? Cancel. Yeah. And the answer is, let me put it. Let me put it in colour to make it more dramatic. That's it. 2 and 3, yes. Now, I understand exactly the reason why people said only 3. And it makes perfect sense, because you think, okay, you feel like you should be able to just cancel these and you're finished, okay? But suppose for a moment that x equals 2. What would this number be? 0. And what would this number be? 0. And it's forbidden to cancel 0 with 0. So in other words, you don't care if anything on the bottom cancels with anything on the top. When you're talking about domain here, just look at the bottom. You have no interest with the top. It's not, they're only going to be a problem at the bottom. Yes, basically you can ignore the top. It doesn't matter if this was, plus 240 or whatever. It doesn't matter. And the reason I did this example is because I remember, in high school I would have thought I can cancel this. And then when I did this at university for the first time and learned I couldn't do this, I hope you had a similar feeling. You feel smarter now, or maybe more confused. I don't know. But anyways, my point is, you only look at the bottom. The top is not important. Okay. Right, we'll just do one more. We'll do one with sign in it, because we haven't done that, and then we'll look at the next problem. So we have fx equals minus 7 sine minus 9x plus 2 plus 8. Okay, so here, what's the domain, do we think? Yeah, you can put any number into sign, so the domain is all real numbers. Okay, so this lesson is domain and range, and I hope you all have a good idea about what domain is. So what do you think range might be? The y's, yeah. It's what values you get for the y. So on the graph, if you were to graph what we're talking about, for example, the square root graph looks like this. Let me do it in a different color. What's the domain for square root x?
0 to infinity.
Yeah. So on the graph, the domain is the values you can use on the x-axis. You can't use negative. The range is the values you get for y. What values do you get for square root? Actually just positive. So square root of 9 is positive 3. Do you get it negatives? No. Technically you don't. So the range is the values you get on the y-axis, what's possible on the y. So I can write that down. The range of the range of fx is the set of all values of fx when x is in the domain. So in other words, it's all the values you get from your function.
We have to take the domain and find the parameter.
Yeah, so that's one way to do it. You can get the domain and use that to get the range. In fact, there's a few ways to do it. You can also get it from the graph. If you draw a good graph, you can get it from the graph as well. But the way I want to show you might seem difficult, but the advantage with the way I'm going to teach you is that it works for every problem. Whereas the method you suggested with the domain and also the other method about using the graph, these don't always work. You know, you can only use the graph if you know how to draw the graph, if it's like a quadratic or something. So I'll show you the method. Well, actually, you know what? No, first I'll show you the graph with an example of a quadratic, maybe. Okay, so let's have a look at some examples. Can I scroll down? Okay. So I have fx equals 6x plus 8. So you can find the range from the graph. You need to imagine the graph, and you need to imagine what values you can get for the height on the y-axis.
Minus infinity to infinity.
Correct, yeah. So if you picture the graph here, what type of graph is it? Linear, straight line graph. So the graph will look like this. So you do get all the y values. So that's the range. The range is all real numbers. Now it gets a little bit more complicated with a quadratic. So the next example is with a quadratic. Oh, by the way, when this happens, when you get this range is all real numbers, we call this function onto. We say it is an onto function. It's just a little bit of vocabulary. Onto, yeah.
When the range is all real numbers.
Yeah. Okay. Next example. Now you know that it's not a linear, it's a quadratic. So the range, is it going to be all real numbers here? No, not actually. If you picture the graph, the graph, you know, it could look maybe something like this. So you see that you only get the y values from here up to infinity. So you can go all the way to infinity, but you don't go all the way to minus infinity, because it's a U-shape. So what you really need to know, what you really want to know on the graph is what this point is here. What's the name of this point? Stationary point or turning point? You have two methods to find it. What are the two methods? The derivative is one method, correct, and that's what I'll use. The second method? Completing the square. So the derivative here is 4x minus 4 equals 0. So what does x equal? 1. So we know that the x is 1. And how can I find the y? Sub it in. So I have 2 minus 4 is minus 2. Minus 2 again? Yeah, so actually this graph is down under the axis, but it doesn't matter. So what is the smallest y value I can get here? Minus 4. Yeah, it's the smallest y value. So what would you say it's not the domain, the range? Yeah, it's minus 4 all the way up to infinity. I've seen this question a couple of times. In fact, in section A and section B, they give you a quadratic and they ask you for the range of it. So basically, they're asking you for the turning point, really. Okay, next example. Fx equals minus 2x cubed minus 3x squared plus 9x plus 6. So picture the graph. What's the range? Is it or is it not all real numbers? Is that what we're saying, not all real numbers? I'm sorry to tell you it is. Because if you picture the graph, it looks something like this, doesn't it? So you do get all the numbers going down and all the numbers going up on the y, right? So what's the range here? All real numbers. This function is called onto.
You will do the graph.
Well, of course, yeah. If I give you the graph, it's not a problem. Okay, so far we've looked at examples where it is suitable to look at the graph to find the range. And now we're starting to move into examples where it's too difficult to look at the graph and we need another method to find the range. So I'll give you a simple example first to show you the method. So I'll give you the method as steps. So the first step is to replace fx with y. So that's the first step. Step 2 is to express as an equation equal to 0. So in other words, rearrange it so that it's equal to 0. Step 3 is pretend y is a constant. So just imagine y is a number, just a simple number. And then the last step, which gives you the answer really, ask yourself what are the values of y so that the equation can be solved. Now, I'll explain this with an example and it will be clear. These values are the range. These values are the range. I don't think you'll find this in any maths book because I just made it up. But the idea, this is as simple as I can make the idea here. And what I really like about this method, the best reason for using this method, although it looks difficult and wrong, is that it works for all your problems. Okay? So if you only wanted to learn one method for these problems, this could be it. So let's have a look at an example now. We'll do, I think I had it up here, yeah, 1 over 12x plus 12. Okay, can I scroll down now? Yeah? Okay, so I need to scroll down. Okay. So we have fx equals 1 over 12x plus 12. Okay, so what's the first step? Replace. So y equals 1 over 12x plus 12. Step 2 is to rearrange this so it equals to 0. So if I bring it up, it looks like this. That's step 2, isn't it? Yeah. So that's step 2. Oh no, that's not step 2. Now this is step 2, finished. Okay, so here to here, that's step 1. Here to here, that's step 2. Now step 3, what's that? Pretend y is a number. So ask yourself, if y was a number, what would I do next? Like if y was the number 5, what would you do next? You'd multiply it in, wouldn't you? If that was just a number in the front, you'd multiply it in. And that's what you're going to do now. So we'll multiply it in. So you have 12yx plus 12y minus 1 equals 0. Now, if y was a number, it would be possible for you to add these two together, wouldn't it? If it was just a number. Right now you can't because you're just pretending it's a number, but what I'll do is I'll put brackets around it so we can imagine that we added it together. And then what about the 12y here? If y was a number, what would you do? You'd multiply it by the 12. So can you do that here? No, because you're just pretending it's a number. So I'll just put brackets around that to pretend we got a number. That's step 3. Now, the last step, which is the key step. We ask ourselves what values of y I can use so that this has a solution. So what type of equation is this? Linear. When will a linear not have a solution? I mean, when will a linear not cross the x-axis? When not x is 0, when the slope is 0. So what do we need here? We need the slope to not be 0 if we want a solution. And if we didn't want a solution, it would be 0. So if I want a solution, the slope needs to not be 0. So what number here is the slope in this formula? 12y. And what do I want for the 12y? Not to equal 0. So what does that mean? Y is not to be 0. So then y should be all the real numbers except 0. And that's the answer. That is the range. The range is all real numbers except 0. Step 4. Let me give you one to try, then I'll do it, and then I'll let you work on these for a few minutes, okay? I'll give you one to try, and while you're doing it, I want to make the graph of this one so you can see the graph. So I want you to try this one for me. Give me the range of this. It's actually 2e. Fx equals 1 over x squared minus x minus 12. It's 2e. Here you go. More difficult, isn't it?
We'll have to find the derivative, right?
Say that word again. Are you using the right word? Derivative? Is that what you meant? Yeah?
Yeah.
I don't think it's derivative. No, you don't have to find the derivative. Something else. Let me just have a look at the graph for the last one. It was 1 over 12x plus 12, wasn't it? So can you see on this graph, it does go all the way to infinity. Yep. It does go all the way to minus infinity, but notice that you don't actually get 0. If you look here, 0, and you go across, you don't actually hit the red line. I know it looks like it gets to 0 here, but if you were to zoom in, you see it doesn't actually reach 0. This graph will never get 0 on the y-axis. 0 is missing. It'll get all the positives, it'll get all the negatives, but it won't get 0. 0 is missing. That's the answer you got, wasn't it? All real numbers except 0. Let's have a look at this one now. So let's use the method I showed you. So we have y equals 1 over x squared minus x minus 12. Step 1. Step 2. Y equals x squared minus x minus 12 equals 1. Take the 1 to the left, so it's minus 1 equals 0. Step 3, pretend y is a constant, so you get y x squared minus y x minus 12 y minus 1 equals 0. If y was a constant, you'd have no problem adding these two together. And then there's nothing to do here, and then there's nothing to do here. Now, the big question. I need to ask myself what I need to do to make sure this has a solution. So how do I make sure a quadratic has a solution? Yeah, go on. What about it?
If it was equal to 0,
Yeah.
then I'm gonna get to solution.
Oh, started so well. What do you need for the discriminant to have two solutions?
0 bigger than 0.
Well, for two solutions greater than 0, yeah. And for one solution? 0. And no solutions? Negative. So in other words here, for this to have a solution, the discriminant, what do you think? Bigger or bigger than and equal to 0? Bigger or equal to 0 will guarantee it has a solution. It's the negative that's the problem. And what is the formula for discriminant? B squared minus 4AC. And we did this in semester 1 also, it should look familiar. So you have y squared plus 48y squared plus 4y bigger than or equal to 0 when I expand. So I have y, what have I got? I've got 49y squared plus 4y bigger than or equal to 0. Is that right? I think so. This has two factors. First factor is y. Y and 49y plus 4. Is that all okay? Something doesn't feel right. Something feels wrong. Yeah. B squared minus 4ac. Yeah, no, it's okay. Okay, so we draw our shape here. What are our two values? 0 and minus 4 over 49. Oh, I don't feel good. I feel sick. This doesn't feel right. Check the answer. No, check the answer at the back. Which one am I doing? E. 2E. Yeah, something. 2E. I made a sign mistake somewhere. Let's go back a bit. Well, first thing that I write the question down right. Is that 2E? Is that 2E? X squared minus x minus 12? Y times x squared minus x minus 12 minus 1 equals 0. Yx squared minus yx minus 12y minus 1. No, sorry, it's right. B squared minus 4ac. Okay, maybe the answer at the back's wrong. I'll check the answer on the computer program in a minute. So we'll continue with this. So what values do I want here? Above or below?
Both.
Above.
Not both of them?
Both of them, yeah. So I want y to be less than or equal to 0, and then y less than or equal to minus 4 over 49, or y to be bigger than or equal to 0. So it looks like the range is all the numbers from minus 4 over 49, minus infinity to minus 4 over 49, and then 0 to infinity is the range. Although remember, something feels bad. So let me check the answer here on the program. So the way I check the answer is I'll get the computer program to draw the graph, and we'll just make sure it looks the same as the answer here. So can you just give me, please, the original? What was it? It was 1 over x squared.
Minus x.
Yep. Minus 12. So graph it. So what two values should I not get on my y-axis? I should not get actually anything between minus 4 over 49 and 0. So there should be a gap on the y-axis, because remember I'm saying the range is minus infinity to minus 4 over 49. Then we skip and go from 0 to infinity. Let's find out. Okay, now I need to zoom a bit here. Right, so look, I go all the way from minus infinity to this number here, which is what, minus 0.075, and then no y, no y, no y, no y. Do I have 0?
No.
I don't actually have 0, and then all the way up again. So can you just give me the decimal, please, of minus 4 over 49?
Minus 0.08.
Yeah, that looks like minus 0.8. No, it's minus 0.18 or minus...
0.
Yeah, so there's 0.05, so that would be about 0.08. There, look, there it is right there. Center here, please. This is where all the action's happening. Center on cross. Yeah. Alright, so I guess the answer at the back is wrong then. So this is it here. Although, we just have to be careful to make sure, here I said greater than or equal to 0. But really, who can tell me why I didn't include the 0? In fact, why did I go with greater than 0? And this one here, I did include it. And why did I not include it here? And if you feel better, none of the students in intake 1 could get the answer as well. So, why did I drop the equal part here? Because look, I have equals here, don't I? And I had it in both my answers, but I didn't use it here. I dropped it. Why did I drop it? Huh?
Because
You get more than one.
No?
we did it in before. You have the origin function.
No?
When you do have one here, one variable here, and one variable there, there is one in the middle.
No, not this. What you're saying here is the original function. What do you mean?
The original function is 1 over something fraction.
Ah, but you can... no, not because of this.
Okay.
Yeah. Anything else?
You can't get there because you can't get zero from the equation where you have.
That's not the reason for dropping it here. No.
Y can't equal zero.
Why? Yeah, why can y not be 0? Okay, time's running out. No one's going to get it. No one.
Oh, you should.
Well, that's nothing to do.
The answer is, what type of equation is this here? Quadratic. As long as what? The y is not 0. If the y was 0, would it be quadratic? No. So I'm only allowed to continue from here if I say the y is not 0. Because that discriminant is for quadratic. And remember I said pretend y is a number. You cannot continue if y was the number 0, because then it's not quadratic. But anyways, if anybody gave me that as an answer, I'd be very impressed, and I would give you 1 million maths points. And you would automatically level up to the next level as well. Okay, so that one is a difficult one here. And the answer is wrong at the back, so I need to fix that as well. I don't think they'll be as difficult as this in the exam though. In the exam they tend to be more like the last one I did, my first example. It is possible that it's like this in the exam, but I think this would be the worst possibility. It's probably the most difficult question you could get in the exam. Not impossible, but just unlikely. Okay, so I'll just let you practice these for a few minutes. You get a feeling about which of the two examples are more important to practice. Yeah, you're right. Okay, so try these for a few minutes.